Okay, this lecture is going to be over section 3.3 and it's going to be over projectile motion. So this projectile motion occurs when an object is given an initial velocity and then follows a path determined entirely by the effect of constant gravitational force. So the path is called a trajectory and it's a parabola in the xy plane. The vertical motion of a projectile is independent of its horizontal motion. So in projectile motion, the acceleration in the x direction is going to be 0. There is no horizontal component of acceleration. And the acceleration in the y direction is going to be given by minus g. It's a constant vertical component of acceleration due to constant gravitational force. So the coordinates and velocities of components as functions of time are set up such that the velocity in the x direction is the same as when it started. If there's no acceleration, there's no reason it would change. The distance traveled is going to be where you start from plus the velocity in the x direction times the time. For the y direction, the velocity in the y direction is going to be the same as your initial y velocity minus the gravitational force times time. And the distance traveled in the y direction is going to be where it starts in the y relative in the y direction plus the velocity in the y direction times t minus 1/2 gt squared. And here you can kind of see the graph of what's going on. You can see the ball as it goes from this point over to this point. The velocity in the x direction is not going to change. The velocity in the y direction, however, is going to go up and then it gets smaller, and then as gravity continues to wear on it, will eventually point down and eventually strike the ground. So you do have some tutor demos here that would be worthwhile to go through. You've seen our discussion there regarding the velocity. You can see here that a projectile moves in the vertical plane that contains the initial velocity vector v naught. Its trajectory depends only on v naught and the acceleration due to gravity. So there's nothing changing here in the x direction, this initial velocity. In the x direction, the y direction, on the other hand, is always being changed because of gravity. So you can see the accelerations being defined here. Acceleration in the x direction is 0. The acceleration in the y direction is going to be minus g. The accepted value here is 9.8 meters per second squared. It's going to be negative because it's going to be pointing downwards. This, again, is the same graph as what we had before. You can see here that at this particular point right here, the velocity in the y direction is 0, and this is where the velocity vector starts to change and instead of pointing up, starts to point down. These are the kinematic equations, depending on which direction you're going in. And that's a nice summary there. Again, these are the x direction kinematics. These are the y direction kinematics, and those will be important in order to be able to solve certain problems. If you are needing the components, the velocity in the x direction and the velocity in the y direction, they can be found by the angle that is made by the velocity direction with respect to the ground, and then taking either the cosine or the sine, depending on which component that you need. Again, you can see here that the velocity vector is going to be the square root of the squared component parts added together. And again, you've got the relationship where the angle that's made with the ground can be found by the inverse tangent of Vy over Vx. So depending on what you need in each one of these problems, you can substitute it in and find what you need. You've got more discussions of problems down here. I would encourage you to go through those.